So we'll start with preparation steps, disposal options, response evaluation, remediation or regulatory strategy, and then a brief regulatory update. So in case this topic is new to anyone, hopefully it's at least something that you've heard of. We're talking about Purge polyfluoroalkyl substances, or PFAS, which are a group of man-made chemicals that include PFOA, PFOS, GenX, and many other chemicals. They, again, are man-made substance. They're resistant to biodegradation. They're miscible in water. They have some affinity to carbon, which we'll talk about. They're usually a mixture. And when we talk about AFFF or Aqueous Firefighting Foam and others, you'll understand the mixture and the challenges that come with that. And they are semi-volatile. So for this audience at 4C, primarily in the oil and gas and chemical manufacturing space, the most likely exposure you have to PFAS is through aqueous firefighting foam, or AFFF, as it's more commonly called. The challenge is that while many facilities have likely reviewed their SDSs over the past year as part of their 2021 TRI reporting, most facilities likely would not have the quantities to meet the reporting criteria part of the TRI. However, when you look at the regulatory environment, parts per trillion is a very low concentration. So while you may not have had large quantities, it does not take a lot to cause parts per trillion detection. In addition, PFAS compounds are hard to identify in SDSs. Barr has reviewed thousands of SDSs to identify that may have detection considerations or concentrations. As you're looking at your current and historic use of AFFF, it's encouraged to interview your staff, even retired staff. These compounds, PFAS compounds, were made in the late 40s, early 50s. They've been used in AFFF for many decades. So while you may not currently have product on site, there is likely historical use. So interviewing those retired staff who understand where you may have had a training facility or a past incident is very useful in understanding your exposure risks. The reporting to agencies has also changed as there's been rapid development and notice by agencies and states. The reporting requirements have changed in the handling rules and regulations. In some states now, if you have a fire incident, you have to report it and minimize the impact to the environment. And this includes incidental or accidental releases, which can be even more common than the emergency events. So even as you may be evaluating your switch to AFFF or the fluorine-free foam, there are some key considerations. System purging. So how do you get rid of the product that you already have in your system? And we'll talk about disposal methods in just a minute. The fluorine-free foam does require some new pumping mechanisms. However, this product does stick to the old stuff. It does stick in your piping. So as you go through and maybe switch out to the fluorine-free foam, there is still risk that you have it hung up in your system. So sampling and testing to make sure you fully purge the system. So I hope by now that your fire chiefs treating AFFF as a best management practice. However, we're talking with many fire chiefs, they like AFFF because frankly it's a and it can save lives. So when you do use it for an emergency use, have a plan. And again, have a plan when you have an accidental release. We have worked with clients to design sites like firewater, have discussed having an emergency response plan and design a rapid treatment on skid ready in case of emergency use. So know where your product would be going, where it would be used, and how it would be used. When you're buying assets, we're continuing to see mergers and acquisitions happen in this marketplace. Understanding the risk profile of the assets that you're buying. Again, where is the historic use of where we're trading grounds? And if you're going to divest assets, know your own liability as you're going to divest those assets. The regulations, while not in place now, they're coming, and you want to understand your liability. And we'll talk about the regulations a little bit later. And then when you have a large, diverse portfolio over different jurisdictions and states, look at your facilities' distance to drinking water sources and the geology. We've been helping clients with evaluating their asset risk profile and understand the different regulatory environment, and understand that there's different regulatory environments that companies are operating in. Texas is different than Wisconsin, Oklahoma is different than Colorado, and North Dakota is different than Minnesota. They all have different criteria. They're looking at this, they have different plans, they're different processes. So understanding where your assets are and what the local regulations are very important. And again, if you're not following this, there is no national federal guidance on PFAS at this point, which we'll talk about, but it's a patchwork. So understanding that the many different states and where they are in the process is important. But I mentioned disposal before, and disposal of AFFF. There is not a lot of clarity at this point on disposal guidance of PFAS, and it's yet to be designated as a hazardous substance. Subtitle, so if you're looking to landfill, subtitle C, landfills are accepting. Subtitle D is getting harder to find facilities that will accept PFAS products. Incineration is the way that you destroy PFAS, but it is becoming more difficult to find incinerators that will accept PFAS substances. And if this is any indication, the news recently that an original manufacturer of PFAS announced they shut down their incinerator and moving that off-site. There is the possibility of deep well injection, especially in Texas. But the problem with deep well injection is that, again, PFAS does not degrade. So you may dispose of the product now, but scientifically it has some issues long term. So response evaluation. Understanding where you are in evaluating risk. The PFAS issue has largely been driven by stakeholders in the public. Driven, if you look at the history, driven out of Michigan at the tail end of the flood water crisis. If you look at other communities, when PFAS is found in their drinking water sources, that's when you have public scrutiny, public opinion. The public is driving this and thus driving legislators and regulators. So you have different local stakeholders, depending on your jurisdiction, different in Texas and New York, it's different from Missouri to Michigan. Looking at your migration paths, geology plays a role with groundwater and surface water flow. Again, look at your receptors. States are ramping up. Wisconsin is ramping up, while some states are waiting for federal action. And federal action is coming. We'll talk about that a little bit later. And being aware of what the locals are doing, what their PFAS plan is. California recently announced that they will be sampling at refineries and terminals to sample for PFAS and their low concentrations. The state is also proposing one of the lowest concentration limits of 0.007 parts per trillion. So it's by far the lowest, and there may be challenges there from a data validity standpoint, but it's the race to zero, really. So know what your local plan is. So with that background, and to the topic of this presentation, the real question is to collect or not to collect. Changing regulatory environment, I think every entity is in a different phase of this. So we'll start as to why not to collect. And the biggest is that data can be discoverable. And what do I mean by data can be discoverable? Lab reports can be discoverable. So when you go out, sample the data that you send to the lab or that you receive back from the lab can be discoverable. But the analysis, our chemist report, to understand what you have, what your exposure may be protected under attorney-client privilege. Though we suggest that you get advice from your attorneys on this. Once you have the data and you don't take action, that could potentially be a question you have to answer in litigation review. Basically, once you collect data, the clock starts, and what do you do with it? So that leads us to why should you collect? First is to understand your exposure prior to any regulatory agency or public pressure. And so you have control of the situation. It allows you and your team to plan and budget. As we'll get into, I won't go into exact costs. I think others from this panel will get into some of the costs to consider. But the treatment of PFAS is not inexpensive. So putting that in your capital projects, your timelines is important to plan. And also to collect to understand your full risk profile will help you understand what your treatment remediation options, again, which we'll discuss. It allows your company to get ahead of the problem again, and again, much of this is coming from citizen pressure. And following trends in states where testing occurs at public water sources or private drinking wells, agencies are looking upstream for contributors. So if you take a state like Wisconsin that has been testing their public drinking water sources and they've been looking at industry, you can get ahead of this and understand what your risk is before the regulators come knocking on your door. And one other consideration, especially for the oil and gas industry, is with increasing environmental, social, and government pressure. Showing action, understanding your risk and showing action on this topic may be drivers to get ahead of potential ESG considerations. So if you do plan to collect data, begin with the end in mind. What compounds would you be required to test for? What are the detection levels? Once you do collect data, keep moving forward with your plan. Develop your objectives ahead of time, develop a plan, and keep moving forward. This can keep you out of trouble when the regulators or others come looking at your data, begin to ask questions. Shows that you have a plan in place and you're working towards mitigation. And experience matters. Cross-contamination happens, it still happens. Bad labs, bad data can get you in trouble. If you haven't seen other presentations or research, the fact that PFAS is so ubiquitous, it's in a lot of things. That includes our waterproof notepads, ballpoint pens, sunscreen, insect repellent. So that can really cause contamination of your data sets. So having a good consultant that can teach your teams or work with you in your sampling can analyze your data to understand where there might be lab interference or other interference is extremely important, especially when you're dealing with having to get per trillion accuracy. have an exceedance of a guideline. The remediation strategies. There are a few different out there right now and many emerging, and I know others will talk about this, but source control, putting a site with active remediation, pump and treat, cap or slurry wall to contain to your site. You will likely still have to manage water. In situ, can inject carbon to slow it down. There are those technologies. Carbon captures PFAS, but releases over time as it's knocked off the carbon. And in situ thermal remediation is in its infancy. And excavation, still have to deal with disposal, which we talked about, and limited options there, and they have high costs. So treatment technologies, absorption. So the typical right now is a 2-vessel of granular activated carbon or a granular carbon, which is in the top left, and ion exchange. The challenge there is once the big challenge with PFAS water treatment is the pre-treatment, and that's where the costs get high. Because everything sticks to carbon, even common things like iron and magnesium, it can fill up that carbon quickly and knock off the PFAS, and then you have the detection. The other challenge is not all PFAS behave the same. Some short chains will come out faster than longer chains, acids faster than sulfonates. And going back to data, understanding and working on criteria with your regulatory agencies is important. Most are heading towards non-detect, and we've heard legislators in Wisconsin say that until there's a better understanding of the impacts of PFAS to human health, they are leaning to conservative numbers to protect their citizens. So really understanding what's the threshold that you need to get to when you're treating PFAS water. So remediation, emerging technologies, there's regenerable ion exchange, there are novel absorption technologies that are being developed, foam fractionation, systems that bubble air through the water, creating a foam that can skim off. Then you're just dealing with the foam. Those are still in development. Those still in development are on-site chlorination technologies. So many different options you can do with water treatment mixtures of ion exchange and sacrificial carbon, so it protects your system. You can treat at the wellhead where you may need more pre-treatment, but take out a larger mass. And thus you dilute yourself below the target you're going for. You can treat the whole wastewater fluid, as you may already have iron treatment. And it all comes down to cost. I believe Mitch is going to go into more detail at a later segment on treatment technologies. But one thing is Barr goes through a feasibility study like Matrix to determine what makes the most sense for your site, adding technology versus cost as we evaluate these treatment technologies. So regulatory strategy. I think one thing you'll probably hear throughout is the development of where this is going. Regulators are still trying to figure out PFAS themselves, and they want a lot of data. So upfront, setting boundaries early and sticking to them as we going back to collecting data, setting boundaries, working with the agencies, understanding what your goals are very important. What are those things to establish? What is clean? What compounds are going to be studied? Some jurisdictions have 30 compounds, some are looking at all PFAS compounds, and there's hundreds of them. Collecting good data, getting good data so that you can defend yourself against against that and stick to your objectives. And what is happening in this with all this regulatory development is once you start sampling, start collecting, stick with your plan. For one site, we were sampling for 16 PFAS compounds, and then the state asked for more. We negotiated with the state to stick to the original compounds, and that was agreed upon. So you'll, as this continues to develop, you may have go in with your plan and have the agencies come back and say, well, we want you to test for more. Work on establishing those objectives ahead of time. And again, this is evolving primarily at the state level, but we anticipate this changing over the course of months and years with the new administration. Something to note that Michael Regan, the new head of the EPA, is not new to PFAS. In his prior role at the North Carolina Department of Environmental Quality, he helped DuPont's Feet to Fire on Gen X. So he's very familiar with the topic and has basically made his career on PFAS to this point. What is happening at the federal? A MCL maximum contaminant level is moving forward through the process. It is a multi-year process, but it is currently going through its process and evaluation. UCMR 5, which is testing public drinking water sources for unregulated contaminants. They're adding 23 PFAS to the list. That will begin testing in 2023, going through 2025. And the other thing that has occurred with, or will occur with UCMR 5 is that they will be testing public drinking water sources that serve a minimum of 3,000 residents. The criteria used to be 10,000 residents. So they're really going to a lower threshold in terms of the number of citizens or constituents that receive the public drinking water sources. And again, if you look at states like Michigan, Wisconsin, and others, once the public drinking water sources are tested and they find PFAS, they likely will go upstream to see what contributors there are to those drinking water points. There was advanced notice of proposed rulemaking designated PFAS as a hazardous substance under CERCLA and RCRA that was posted to the Federal Register on January 19th, one of the last actions of the Federal administration. That has since been pulled by the Biden administration. However, in June of this year, the state of New Mexico wrote a letter to EPA asking EPA to determine PFOA and PFOS should be listed under CERCLA. By rule, by statute, the EPA is required to respond to this written request within 90 days. So EPA will be issuing a determination by mid-September this year. The focus, primarily from my understanding, has been on the H chain, PFOA and PFOS, but they could use this as slug to look at other PFAS compounds. And one more, the destruction disposal guidance, there's document is more of a status document talking about what may be feasible and has no real guidance. This was required as part of the National Defense Authorization Act in 2020. So this was produced, but does not really tell anyone anything. And again, state rulemaking, it's a patchwork right now. Minnesota has released their health risk limits for multiple PFAS. New Jersey scheduled a hearing for PFAS in PDS permits. New Jersey is also working toward biosolid pools sooner rather than later. Again, California requiring terminals to investigate for PFAS, and multiple states are continuing sampling programs. So, key takeaways, and I appreciate everybody's time this morning. Evaluate your AFFF use and removal. Again, if you have not ceased trading with AFFF, highly recommend that to reduce your exposure. Prioritize your risk. Develop a remediation strategy. Develop a regulatory response strategy. And be deliberate with collecting data. Collecting data, again, could be useful in understanding risks. But once you do collect data, it does start your clock. And work with an experienced consultant that understands the differences, can work through these with you, and look for alternative ways to analyze your risk without collecting data until you're ready, and they can help you with the data collection. With that, I welcome any questions. And I will say we will have a panel at 4 o'clock this afternoon. We'll have speakers here today to answer more questions. I appreciate everybody's time. I do enjoy the 4C conference. I'm disappointed I'll be missing everybody in person in Spasmatics tonight. But thank you for your time.